Welcome to Chemistry World. Today, let me discuss about core topics for NEET exam from chemistry subject. Core topics for NEET exam from chemistry subject. We know chemistry has three parts. The first one is inorganic chemistry. Inorganic chemistry. Second part is organic chemistry. Organic chemistry. The third part is physical chemistry. The third part is physical chemistry. In these three parts of chemistry, the most core topics in each part that we see. Actually, the weightage of these parts in NEET exam is chemistry weightage is 30 to 35% will be there. Organic chemistry weightage in NEET exam is 30 to 35%. Physical chemistry weightage is 35 to 40% will be there. 35 to 40%. And remaining percent, 35 plus 35, 70 or 35 plus 40, 75 means 25 to 30% inorganic chemistry will be there. This is the percentage. This is the percentage in NEET exam. Inorganic chemistry will be 25 to 30 percentage. Organic chemistry will be 30 to 35 percentage, and physical chemistry will be in 35 to 40 percentage will be there. Don't consider is NEET exam is biological students exam, so physical chemistry will become less. Never will be that. Most percentage will be there from physical chemistry itself, 35 to 40%. So now let's come to the topics. The core topics in inorganic chemistry is, the first core topic is chemical bonding. Chemical bonding. In this, once again, core topics, it is a main lesson in chemical bonding, comes under inorganic chemistry. Chemical bonding. First and most important lesson is chemical bonding. After that, next important lesson is coordination compounds. Next important lesson, coordination compounds. During revision, first we have to consider these topics as a core topics. Most of the questions will come from these topics. Most of the questions, how that questions will be there, and in these lessons, let me discuss some important topics also. Not all topics important. During revision or last moment of the NEET examination, before 10 days or minimum 7 days or 15 days before, don't go for new topic and don't read all the topics in the lesson. Please concentrate and focus on most important topics. So in chemical bonding, some most important topics are there. In coordination compounds also, most important topics are there. Let me go for later what are the important topics in chemical bonding, all these things. Next important topic in this is p block elements. P block elements. In this, not all topics are important. Let us see what are the important topics later. After that, fourth important topic is periodic properties. Periodic properties. In this also periodic properties. And the last one is important lesson is qualitative analysis. Practical chemistry, we can say it is qualitative analysis. In this also, don't go for depth. Some main, how to identify cations and how to confirm the cations, what are the groups are divided in the cations, and what is the precipitate and what are the group reagent in cations, like that. We know cations have been divided into 6 groups. Each group has a particular reagent. So let me discuss that one later. So these are the core topics in a inorganic chemistry. Core topics in a inorganic chemistry. Next, important topics in a physical chemistry. Let's go for important topics in a physical chemistry. Once again, I'm saying, please revise as many as times these topics. Please focus mainly as many as possible to you, or else you cannot get the marks in NEET exam, especially in physics. Last time we know chemistry paper was very tough in a NEET exam. So please focus these topics. Most of the questions in previous exams came from these lessons. These are not the topics, these are the lessons. In these lessons, once again, important topics are there. Let me go one by one after writing the important lessons in this physical chemistry as well as organic chemistry. The first and most important topic in physical chemistry is thermodynamics. Thermodynamics and thermochemistry. Thermodynamics and thermochemistry. This is most important topic in physical chemistry. First one is thermodynamics and thermochemistry. After that, next, equilibrium. Second lesson is equilibrium. Second lesson, equilibrium. That equilibrium comes both chemical equilibrium as well as ionic equilibrium. You have to concentrate on both the, in this not all the topics, and in that lessons also core topics are there, but we see that one later. First I'm writing topics, then I will go for subtopics, and there will let me discuss some problems on each topic. Don't no need to write all the topics at the time. So next topic is chemical kinetics. The third one is chemical kinetics. Chemical kinetics is the main topic. And after that, next important topic is electrochemistry. Before that also, of course, you can say this as the fourth important topic. The third important topic is electrochemistry first. Electrochemistry. After that, the fourth topic in this is fourth topic here. After that, I'm writing here fourth topic is chemical kinetics. Chemical kinetics. So in this also not top all topics are important. Some core topics are there. Let me discuss that one. After that, the next fifth one is solutions. Next one is solutions. Definitely solutions lesson also important in that. And solid state also, solution, solid state, both collectively we have some core topics. Let me see that solutions and solid state. Solid state, from these two topics, these are the core topics. 5 topics in inorganic chemistry important, 5 topics in physical chemistry, 5 lessons or topics we can say, total 10 topics. Total 10 topics. So next, organic chemistry. What are important topics in organic chemistry? So these main topics, in this not all the topics important in these lessons also. Next, let's go for organic chemistry. Here I'll write the topics for organic chemistry. The first topic of organic chemistry is, first and most important topic for organic chemistry is, yes, named reactions. Irrespective of the lesson, irrespective of the topic, named reactions. I think in board examinations, you have practiced many named reactions. Once again, you have to revise these named reactions. Let us see some problems in these named reactions. I'll go next videos. I'll discuss how the named reactions will become in this one. After that, the second important topic in organic chemistry is IUPAC nomenclature. IUPAC names. In previous videos, I have IUPAC, how to write the IUPAC names. So you can go through that videos. it will be there. So next, in this case only, you can say acidic nature and basic nature of organic compounds. Acidic and basic natures. After that, the third topic in this is we have to concentrate mostly on biomolecules and polymers. Biomolecules and polymers. Biomolecules and polymers. After that, the fourth important topic is uh, mostly what you can say, that is aldehydes, ketones and carboxylic acids. Aldehydes, comma, ketones and carboxylic acids. Carboxylic acids. After that, next core topic in this case is you can say electronic effects. Electronic effects. Electronic effects means inductive effect, resonance effect, hyperconjugation, like that. I effect, R effect, I effect, R effect, and hyperconjugation, main topics. Hyperconjugation, like that, important in electronic effect. And these how they influence on a carbocation, carbanion, carbon free radicals. Dot means free radical. How they influence the stability of that. Same acidic nature, basic nature also depends on this. So these are the 5 core topics in a NEET exam. Organic chemistry, first and most named reactions, irrespective of the topic. Let us see how the questions will be there. So IUPAC names, biomolecules and polymers, aldehydes, ketones, carboxylic acids, electronic effects. These are core and important topics. And sixth topic is also there, that is hydrocarbons. Hydrocarbons. Hydrocarbons means alkanes, alkenes, alkynes, benzene. So there, how the questions will be there, please practice on this. These are the 6 topics from organic important. 30 to 35% mostly come from these lessons. 25 to 30% mostly come from these lessons. 35 to 40% mostly come from these lessons. So these are the core topics and important topics. Most probably the students will get problem in these topics. So remaining topics, theory topics, that is secondary important we have to give. The first importance should be there for this. Now, in this, let me start the first topic, important topic in inorganic chemistry, that is chemical bonding. In this lesson, what are the core and mostly previously asked question topics? Let me see now. So this is topics and percentage division. So anybody, you can check all these things, and in Google also, or in online also, and in your colleges also, most of the lecturers and most of the known persons will be say these topics as the important. From my knowledge and from my experience and from searching all the sources, I have identified these topics as important. And previous examinations also, if you see, many questions will be there from these topics. 5 lessons from inorganic, 5 lessons from physical, 6 lessons from organic chemistry how to take. And how many lessons you will complete, how you can cover, that depends upon your ability. But one thing I can say, those who are practicing NEET and those who have the goal must and should have to go through this one. And once again, I'm saying, if you are not completed these topics, don't be panic. Please keep calm. Don't be get any tense, and just try to solve the problems as many as possible to you. I'm saying these are the important topics. So as many as possible you have covered, that much of marks will become. So thank you. Let's go for next. I'll discuss important topics in this chemical bonding, and let me see how we have to discuss. I'll explain in detail each topic of chemical bonding lesson in this class. Now, let us start chemical bonding. In chemical bonding, there are so many topics are there from starting how the chemical bonds are formed, what are the chemical bonds are there, and what type of bonds are present between the atoms and molecules, and what are the bonds present between metal and metal, metal and non-metal, 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 like that. That is the fundamental things. Fazan's rules, octet rule, Lewis structure are not important. Of course, they are basic points, but the main important topics in a chemical bonding is, in chemical bonding lesson, chemical bonding lesson, the core topics, we can say important topics are, the first one is hybridization. First one is hybridization. Must and should you have to practice hybridization. If you are not practicing any question from the hybridization, it's a waste of thing to think about the chemical bonding, waste of thing to think about a NEET exam. So, once again I am saying, for chemical bonding lesson, the core and first most important topic is hybridization. After hybridization, next important theory. In this hybridization only, VSEPR theory can be covered. VSEPRE theory can be covered. Hybridization and VSEPR theory, that is valence shell electron pair repulsion theory, we can cover in that. After that, molecular orbital theory, MOT, is most topic. Many questions will become from this topic, hybridization, molecular orbital theory. After that, next important topic is formal charge, formal charge and Fazan's rules. Formal charge and Fazan's rules will be there. I am writing priority order. I am not writing topic order from the lesson. I am writing priority order. Hybridization is the highest priority, VSEPR theory, and after that second priority is MOT, molecular orbital theory. Third one is formal charge and Fazan's rules. Fourth topic is, if you can solve dipole moment. If you can solve dipole moment. So these are the core topics. These are the important and core topics. So many questions are there from these topics. Let me see now one by one topic. Let me discuss. I will explain in detail and basic simple things required to understand hybridization, required to solve the problem from hybridization. So let me start. The first topic is VSEPR theory and hybridization. VSEPR theory and hybridization. I'm not discussing the important postulates of these things and all this is symmetrical and non-symmetrical. It's a waste of time. First, how to identify hybridization. The first topic in chemical bonding is hybridization. Hybridization and VSEPR theory also we can say. Hybridization and shape of molecules. Shape of molecules and number of lone pairs. Number of lone pairs. All these things we can be identified in this stuff. Only one formula is there. I'm saying once again, only one formula is enough to cover entire hybridization concept as well as entire VSEPR theory concept. For any molecule, we can identify its shape, its geometry, and its number of lone pairs and bond pairs. Only one formula. That one formula is enough. What is that formula means? Number of hybrid orbitals. Number of hybrid orbitals equal to 1 by 2 V plus M minus C plus A is the formula. In some cases, at the place of M, some other symbol will be there, and at the place of C, some other symbol will be there, A, some other symbol. From my knowledge and from my concept, I'll explain number of hybrid orbitals by this formula. V plus M minus C plus A. So what is V means? Number of valence electrons of central atom. Valence electrons of central atom. Every molecule has central atom. So number of valence electrons of central atom. M means number of atoms can form single bonds only. Forms single bonds only. No multiple bonds. Means no double bond, no triple bond. Those atoms which can form single bonds are M. Simply we can say it as monovalent atoms. Monovalent atoms. M for monovalent atom, or the atoms are which can form a single bonds. Single bonds are called M. C means charge of, or else we can say positive charge, amount of positive charge, we can say amount of positive charge, amount of positive charge if this given molecule is cation. If it is not cation, just write down C as a 0. If it is cation, write down how much of positive charge is the amount of positive charge of cation. If it is cation. If there is no cation, just write down it as 0. And what is A means? Amount of negative charge of anion. If it has the negative charge, generally negatively charged ions are called anions, positively charged ions are called cations. If positive charge is there, write down amount of charge as C. If negative ion, that is anion, is there, write down amount of negative charge as A. If it is not there, write down it as 0. This is the core formula to calculate both hybridization, shape, number of lone pairs, and number of bond pairs also you can calculate. Number of bond pairs you can calculate from this. And from that you can say the shape of molecule. Let me go for one by one molecule, from simple molecule to concept molecule, that is previously asked questions also we can see. First let's go for simple question, simple molecule. I'll write two examples for neutral, two examples, for one example for positive ion, one example for negative ion, or else if you have any examples, just give it to me. I'll or send in the comment, then I'll explain according to that. For any molecule, just use this one and just observe how I am solving. If you go through like that, you can say any molecule structure. I'm going to first, previously asked question only is there. Example 1. I'm taking how to identify number of lone pairs, number of bond pairs, geometry, shape. Let me see now. First molecule is what you can take, only symmetrical molecule. Let me take, that is best example ClF3. Previously asked examples only I am taking. What is the shape and what is, how many number of lone pairs and how many bond pairs are there in this molecule? Let me see. ClF3. This is previously asked question, that's why I am taking this one only. So now in this case, chlorine is central atom. First identify central atom, then let me calculate number of hybrid orbitals. Number of hybrid orbitals. Number of hybrid orbitals already told you. The formula is 1 by 2 V plus M minus C plus A we can write. So in this, central atom is chlorine. So 1 by 2, chlorine belongs to 17th group. So it has 7 valence electrons, and fluorine also 17th group. Its valence is only 1. Its valence is 1. Why? Because 17th group valence is 8 minus number of valence electrons. Number of valence electrons in 17th group is 7. So 8 minus 7 is 1. So means fluorine forms only one bond. They are 3 are there. No positive charge here. So 0. No negative charge here. So 0 you have to take. 7 means valence electrons of central atom. Here the chlorine is there, so its valence electrons are 7. 3 means that is number of monovalent atoms, that is number of atoms which are forming single bond. Here fluorine is can form only single bond, so they are 3 are there. I wrote like this. After that it will be 10 by 2 means 5 are there. Number of hybrid orbitals we are getting 5. We are getting 5. 5 if hybrid orbitals we get, the hybridization will be sp3d hybridization. The hybridization will be sp3d. If 5 hybrid orbitals are forming, definitely the hybridization will be sp3d according to VSEPR theory as well as hybridization concept. So sp3. In this 5, if you observe one thing, only 3 fluorines are there. Means these 3 fluorines can form only 3 bonds. That's why it has only 3 bond pairs. The 3 bond pairs are present in 3 sp3d hybrid orbitals. Total 5 sp3d hybrid orbitals we are getting. In the 3 sp3 hybrid orbitals we will get 3 bond pairs. Remaining 2 are lone pairs are present. So in ClF3, in central atom, 3 bond pairs are present, 2 lone pairs are present according to like this. So how I wrote these 3 to, once again I am saying total number of hybrid orbitals I am getting 5. In that only F3 is there. These 3 fluorines only are there. So that 3 fluorines form 3 bonds means there are 3 bond pairs are there. Remaining 2 hybrid orbitals contains lone pairs. So 3 bond pairs, 2 lone pairs are in this molecule. And one more thing, if the hybridization is sp3d, geometry of this molecule is trigonal bipyramidal. TBP we will write shortcut. Trigonal bipyramidal. The full form is trigonal bipyramidal will be there. Bipyramidal. It is geometry. Remember, it is geometry. It is geometry. If the molecule, if the central atom has lone pairs, remember, if central atom has lone pairs, at least one lone pair, at least one lone pair or more than one lone pairs. If central atom has at least one lone pair or more than one lone pairs, geometry is not equal to shape. Means geometry different, shape different. If the central atom has lone pairs, at least one lone pair. If no lone pairs, if all are the bond pairs, geometry is shape. Means if central atom does not have lone pairs in its valence shell, does not have lone pairs, only bond pairs are present, only bond pairs are present, only bond pairs are present, then geometry of the molecule is equal to shape. If lone pairs are not there, if only bond pairs are there, geometry is equal to shape. Geometry depends upon hybridization. Shape depends upon hybridization, lone pairs, bond pairs. Geometry depends upon only hybridization, but shape depends on hybridization, bond pairs, lone pairs. So here in this molecule we have 2 lone pairs, so geometry not equal to shape. So what is the shape will be seen by VSEPR theory. If trigonal bipyramidal geometry, let me write the trigonal bipyramidal shape like this. Chlorine is a central atom, and remember in trigonal bipyramidal there are 2 types of bonds will be there. One is equatorial bonds, Another one is axial bonds. These are called axial bonds. Axial bonds with angle 90 degrees, and these are equatorial bonds. This is equatorial bond. Equatorial bonds. Equatorial bonds. Two types of bonds are there in that. Axial bond, equatorial bond angle is 90 degrees. Equatorial angle is 120 degrees will be there. But in this case, only three bond pairs are there, lone pairs are there. Remember, lone pairs always occupies equatorial positions, never occupies axial positions in a TBP geometry. TBP geometry means trigonal bipyramidal geometry. Only equatorial positions means here there is no bond. One lone pair is present here, and here also there are two bonds, na? So that's why I'm taking. No need to take this one. Now here also one more lone pair will be there. So like these two lone pairs occupies equatorial positions. Remaining three positions means here axial positions, and here equatorial. One equatorial position, two axial positions occupied by three fluorines. And one more point, more electronegative atoms always occupies axial positions, never occupy equatorial position. Why? Because equatorial position is close to central atom, axial positions are far, because axial bonds are lengthier than equatorial bonds. They are lengthier. These are length bonds. These are short bonds. Generally, equatorial bonds are short, axial bonds are lengthier. So, more electronegative atoms always occupies axial. Due to this, if you see the structure, it looks like T shape. So, the shape of ClF3 molecule is T shape, but geometry is trigonal bipyramidal. Hybridization is sp3d. Like that, you have to identify. Once again, I am saying this is the molecule. For this, we are identifying shape. This is a molecule. For this, we are identifying number of lone pairs and bond pairs. First, we have to identify number of hybrid orbitals. By using this formula, I got 5. If we are getting 5 hybrid orbitals, definitely according to hybridization concept, it will be sp3d hybridization. DsP3 or sp3d. Mostly DsP3 is very rare condition. sp3d will be only there. So sp3d. If the sp3d hybridization will be the geometry will be trigonal bipyramidal TBP. But here there are no 5 bonds are possible. Why? Because only 3 fluorines are there. The 3 fluorines forming 3 bond pairs. Remaining 2 will be there as lone pairs. So here it has 3 bond pairs, 2 lone pairs. So based on VSEPR theory, if the central atom has lone pairs, geometry is not equal to shape. This is according to VSEPR theory. This is according to VSEPR theory. If central atom has at least one lone pair, geometry never becomes equal to shape. If central atom does not have lone pairs, only bond pairs are present, geometry equal to shape. So number of hybrid orbitals gives hybridization, hybridization gives geometry, and lone pairs bond pairs gives shape. So here 3 bond pairs, 2 lone pairs are there. So geometry is not equal to shape. According to that, I wrote first geometry, and then I wrote the position of lone pairs. Lone pairs always occupies equatorial positions, and high electronegative atoms, more electronegative atoms always occupies axial positions. 2 axial positions occupied by 2 fluorines, and one more fluorine is there, it is occupying another equatorial position. Due to that, we are getting T shape. This is the way to calculate hybridization, lone pairs, bond pairs, geometry, shape, hybridization concept, VSEPR concept. All are comes under only one shot. This is the formula to identify that shot. To like this we have to identify. Thank you.